Hello there, happy physics students. This is your physics class that will take the place of the Monday, January 25th class. And this is Saturday night, but there's so much snow out there, I'm pretty sure that there's not going to be class by Monday for all the time it's going to take for clearing all the side streets and so forth. So, assuming that there's no class, I'm putting this video up, so if you see it on Sunday, you may get a head start, or you can watch it on Monday as we discussed. So, hope you're having a nice snow break, and we'll dive right in here. On Friday, we had this discussion. We talked about what was called period and frequency. If you have your day, I think it was day 4 notes, you can add to it. If not, just put them on a piece of paper, and when we get back to school and you've got your physics notebook, we can put it in there in your notebook in the Mod 7 section behind the day 4 note paper, and that'd be fine. So, if you don't have your paper, start with these notes, and we discussed the period was symbolized with the T, perhaps for time, because it is the time to complete one revolution. And the frequency is the number of revolutions in 1 second. So it turned out we discussed that time is the reciprocal of frequency, and frequency is the reciprocal of a period. I said time. All right, so the unit for period was seconds, and the unit for frequency is 1/seconds, which we baptized Hertz, Hz. All right, that was what we ended with last time. So let's do a problem so we can see how all this works mathematically. So let's say we have something running in a circle. Say a frantic dog. Alright, my frantic dog here. And the dog is running in a circle. So the circumference of the circle is known. The circumference is 2.3. So frantic dog. Write this on your own note paper. 2.2 meters is the circumference, and the speed that the animal is uniformly running is 1.6. Amazing dog. He runs at a constant velocity, 1.6 meters per second. And I want you to find the period. So, the period is time, and we know the relationship between time, velocity, and distance. Time is always distance divided by velocity. So that will get us the time it takes to go around the circle. The distance around is called the circumference, so we put a 2.2 meter in that spot, and velocity is given at 1.6. So when we tippy-tap that in, we get out 1.4 seconds. So that is a period, time it takes a frantic dog to the time to complete one revolution, 1.4 seconds. If I ask you, which I do, to find the frequency, if you hear a noise in the background, it's the snow plows. And frequency is a reciprocal of period, so I can just take 1.4, put it underneath of 1. So 1.4 is over an unwritten 1. So when I find the reciprocal, I flip it. So the 1.4 ends up in the denominator, and the 1 ends up in the numerator. Tippy-tap that. It's going to be Hertz. And I'm going to get 1 divided by 1.4, which is 0.71. Alright, so I tried a problem. Now you try one. I'll give you this problem to do, and see if you can get it, and bring it to class next time. So, OYO 7.6. You probably don't have your books. I'll describe the problem. It is a train this time. Again, everything is in a circle, this mod. So a train, let's see. Okay. Oh well, I'm not too good at trains here today. All right, a train is going around in the circle. Its speed, so make the sketch and write down the information of the problem. Speed is 1.8 meters per second. We'll say the radius of the circle. So R stands for radius, 0.81. So I'll just kind of draw that in, 0.81, and that is in meters. And I want you to find the period, which is t. So again, the time to go around the circle. So I will let you work on that. Just stop the video and try that. And when you've got an answer, turn it back on. All right, here we are. After you've tried it, we know that period is distance divided by velocity. The distance wasn't given, like up in here we were told circumference, but here we were told radius. We can get to radius, from radius to circumference, to 2 by using 2 pi r. So 2 pi and the radius is given as 0.81. So that takes the place of distance. Divided by the velocity, and the velocity was 1.8. And when I tippy tap that in, I got out 2.8 seconds. Hopefully you did too. Alright, so shout out to all those who got 2.8 seconds. Now find the frequency. So it's going to be 1 over 2.8 seconds, and that will be in hertz. And when we tippy tap that, we get 0.36 hertz. Alright, the next one I'll give you one more to do. The next one I will give you is, I will give you the setup and the answers, and you see if you can supply the in-between. Anyone who doesn't get it can ask about it when I get together with you again in class. So let's say we have a car going around in a circle. Mine's a smart car. And say it goes around 10 circles. And it does that. It's like a toy car. So it's going around the circle 10 times, and it takes it in 10 circles in 1 minute. And I want you to find the period and the frequency. And just a word of precaution, work in seconds, so you'll have a bit of a conversion there. Alright, so find those. I got the frequency first, because that was given in this information. I got 0.17 hertz. And then for period, I got 5.9 seconds. Alright, so you can work with that and see if you can get those two answers to flush out. Alright, so that's all I want to say about period and frequency. So we're going to go on and talk about something else. Seems like the main players, the main ideas that we've had in this mod have been force centripetal, which is mv squared over r, and then we did force of gravity. Force of gravity is big G m1 m2 over r squared, and then we came to period, and that was distance divided by velocity. Well, I thought it'd be really cool if we could put these all together. So let's think of a way to use this, this, and this in the same problem. So that deserves some kind of special drum roll, don't you think? Let's see if I can come up with a drum roll. So hold on while I pull it up on my computer. Try to make it a little louder than it normally is. Hope this, you can adjust your sound, right? So you want this loud to get the rhythm of it. Alright, so here's my drum roll before I put all those things together. Ready? cool. Okay, how's that for a drum roll? Not bad, huh? All right, so with that build up, let's see how we can put these three things together and come up with some cool stuff. Here's what I want to do. I know that planets almost always orbit in circles. And that's because there's centripetal force in play there. Where does that centripetal force come from when we're talking about a planet? So let's take a planet. Let's take Mars, for example. Any planet would do. Their orbits are almost completely circular, and because we're studying circles, we know that circular motion is caused by centripetal force. But what is providing that force? Well, we've also alluded that it's gravity. Gravity from what? The sun. The sun is at the center. The gravity from the sun is what provides the centripetal force for the circular motion of Mars. So I want to know, how fast does Mars go? All right. We're going to answer that question on part 2 of this video. So I'm going to close it down now and start at part 2. So I'll see you in a few.